Hello everyone, this is Safa and welcome back to the AUV Fundamentals series. This is episode 3 where we explore the different sensors used in autonomous underwater vehicle. Sensors are the eyes and the ears of an AUV, allowing it to understand where it is, how it's moving and what is around it. AUVs operate in a challenging environment where GPS is not available underwater. To navigate and maintain a stable motion, they rely heavily on sensors. Sensors also allow the vehicle to understand the environment, avoid obstacles, and collect scientific data. We can group AUV sensors into a few categories. Navigation sensors like IMUs, velocity sensor like DVLs, depth sensor for vertical positioning, and perception sensors such as camera and sonar. The IMU measure acceleration and rotational speed. It is essential for estimating the AUV's orientation, roll, pitch, and yaw. However, IMUs suffer from drift and noise, so they are often combined with other sensor fusion. A depth sensor simply measures water pressure. Since pressure increases with depth, the AUV can calculate how deep it is. Depth sensors are very accurate and form one of the most reliable feedback signals for underwater control. A DVL uses Doppler shift to measure velocity relative to the seafloor. This allows the AUV to track its motion even when no external positioning system is available. Cameras are great for close-range navigation and mapping, but underwater visibility can be limited by turbidity light absorption and scattering. Well, sonars are crucial for long-range perception. Forward-looking sonars help with obstacle detection. Side scan and multi-beam sonars are used for mapping the seafloor. No signal sensor is perfect. Sensor fusion combines IMU, DVL, depth sensor, and sometimes cameras to estimate the vehicle's state more accurately. Okay, let's go to the MATLAB here. Simple IMU noise example, white noise on acceleration. Okay, here we simulate a simple IMU acceleration signal with additive noise. This shows why raw sensor data must be filtered before using it in controllers. Okay, run. And you can see IMU noise simulation. Okay. Okay, in summary, AUVs combine several sensors to estimate their state and understand the environment. IMU provide orientation. DVL estimate velocity, depth sensors give a vertical position, and sonar or cameras help with perception. Okay, thank you for watching this episode. In the next video, we will discuss reference frames and coordinate system used in AUV navigation, a key foundation before writing controllers. All MATLAB codes are available on GitHub.